Okay, folks, let's start. So this is the TCPM meeting. I welcome all of you. If you're interested in TCP modifications and minor extensions, this is the right working group for you. And by the way, for those who don't know, my name is Michael, and Yoshifumi is the second co-chair here. Unfortunately, Michael Tüxen, our third co-chair, couldn't make it here on short notice, but I think he will attend the meeting remotely. This is an IETF working group, so please note well the usual statements and conditions on participating in an IETF working group. Since this is not the first day in the IETF, I assume that most of you have seen this before. Regarding the logistics, Gori is our primary note taker, but we will try to use Etherpad, and of course it would always help if we have additional note takers. So in particular, if you make comments on the mic, we would really welcome if you could check afterwards in Etherpad whether your statements have correctly been reflected, or for example also if your name has correctly been spelled. We will look at Jabber, but if somebody else could monitor Jabber as well, I mean, this wouldn't do any harm. Whenever you go to the mic, please clearly spell out your name so that we can record it in the minutes. And finally, our usual logistics comment is that please use Tcpm in draft names whenever you publish IETF documents or working individual drafts that could fall into the scope of this working group. We have an agenda with quite a number of presentations. So after this working group status update, we will have a quick update on the EDO given by Wes on behalf of Joe. Then Wes will have a longer readout on the current status of 793 BIS, and we will discuss how to move forward this. After this, we will discuss RAC. We will discuss the ABE. We will have a remote presentation from Mark Ullman on RTO. And then we will head on with the individual documents in this session, starting with the 2140 BIS and the discussion on 64-bit byte numbers. And the session will be completed by an update on some recent changes in TCP in the Windows stack. So are there any comments on the agenda? Okay, I think there are no comments, so we will move forward. I'll give a quick update on the status of the TCPM working group documents. We have not published an RFC since the last meeting, so this is not perfect, but we hope that this will improve soon. We have two recent working group last calls, one for Cubic and another one for data center TCP. The one for data center TCP has triggered quite a bit of feedback, and I think yesterday we've seen a draft update. So this working group last call can probably be completed very soon once we have a confirmation that the comments have been addressed. So this document is expected to move forward to the ISG, hopefully within days even. For the Cubic one, we will have to discuss a bit on the next slide what exactly we will do next. Regarding the active working group documents, we have the accurate ECN document. My understanding is that there is ongoing work by the authors. We have no presentation on that right now. We have a presentation on ABE. For the Cubic one, as I have just mentioned, we had a working group last call. The deadline has finished, but I think we had only one or two comments. So those comments have to be addressed. So we are waiting for an update for that addresses these comments. But still, since the feedback has been relatively low, it would clearly be of interest of us. So if you could have a look at the document once again, as in particular also when we incorporate the feedback that we got, we might ask again for feedback, simply because this is, even if it's an informational document, it's an important algorithm that we would like to document, and we would like to ensure that the document is in good shape. So, also please, if you have read the document, if you have either identified anything that could be missing, or even if you think that the document is in absolutely perfect shape, it would be good to let us know. As I said, for data center TCP, we are in a better shape. We got a lot of discussion. I think the level of review that we received is sufficient for moving it forward. Then we have a couple of other working group items that will all be discussed in this meeting, so I don't have to say much on that. So basically, all are under active discussion on the working group, and we will discuss them in the next sessions. And I'd like to complete this chair presentation with one update on something that is going on in another working group. We had the discussion on that, I think, in Berlin, that there's in the Lightweight Implementation Guidelines Working Group a document on how to implement TCP on constrained nodes. So this document was discussed yesterday in the working group. There have been some recent changes to it. Specifically, it's now heading towards an informational document, and some of the comments that I have raised as individual computer have been addressed. The chair suggestion, the AD suggestion is that somebody who is familiar with TCPM should become a co-author to this document to ensure that the guidance is aligned with TCPM, and also to ensure that, for example, a repeated readout of the work is possible in TCPM, and a victim has been found for that. And of course, our objective is to do the usual thing that we do in TCPM. So I have stolen here an illustration from Michael Wexler. I have no specific idea who he could have met in mind for this specific illustration, but we will do our best to ensure that exactly the status visualized on this slide here will also be achieved for this specific document. And that's basically all that I have on the chairs. So are there any comments, feedback, thanks on the overall working group status? If so, speak up now. Okay.
Mia Kuhlmann on the accurate ECN stuff. So it's totally my fault. I missed to address some feedback I had. So I will update the document hopefully soon. But then I think it's actually ready. So I don't think we have to wait for the next meeting to make a last call.
Okay, also to be honest, I've not read it myself recently, but anyway, I think having a document update would be good, and then we'll have a look.
But I would like to wrap this up soon.
Okay, if there are no further comments, we will move forward, and the next one would be Wes with EDO.
Okay. I'm Wes Eddy, and so the EDO option work has been going on for a while. You can go to the next chart. I think we only have one chart, so pretty brief. The goal here was to help a lot of people that all needed to send big options to be able to do that. However, no one aside from a student that Joe's working with has implemented it yet. So apparently people didn't need it as badly as we thought. But if other people are ready to try this out, it's very stable, mature document, and I don't think there are big open issues. I think we're just waiting on the implementation experience to move forward. So, I don't know what else to say other than you know, implementation and experimentation is encouraged at this point.
Yeah, exactly. I mean, from a chair perspective, I mean, this document is relatively stable for what we know about it, but experimentation would be highly welcome. And at the moment, we somehow wait for that. I mean, as the document is relatively stable, we are not in a rush to publish it, but of course, at some point in time, we would like this to become an RFC, and if we have to figure out how exactly to get there. But at the moment, I think implementation experience is the key thing for that one.
So
We would like to understand of off-road interaction. So, but that's right. The current status seems to be a little ambiguous.
yeah, so what I'd be interested in, while we have people in the room and I'm holding microphones, is actually just asking, do people plan to try this out or experiment with it, or yeah? Originally it came about because we had the TCP crypt and MP TCP and
Yu Chongchen here. EDO doesn't work with GRO, and we are moving to 100 gig NICs. So unless this really gets solved, I don't really know how this can be practically used on high-speed networks. Maybe on low-speed one if. And I think it's actually a bigger issue because there are other drafts that have issues with TSO and GRO, and both mechanisms are actually never been clearly documented in IETF. So it's not just EDO specific, it's overall a problem. And I think for that draft, that's my biggest concern. Practically, we can't really use it, at least at Google, because we need GRO. GRO is critical for kernel implementation of TCP.
So I think in the current draft, it's able to detect if something like GRO has messed up the segments, and the guidance is to fall back to not doing EDO. Right.
Yeah, I understand the fallback. I'm just saying that practically then EDO won't be used.
Sure.
Yeah.
Sure. GRO effectively disables it.
Hello? Hello, am I on the queue? This is Joe Touch. It's incorrect to state that it doesn't work with GRO. It is more correct to say that there is a bug in GRO, because GRO is supposed to be prohibited from coalescing segments that have different options in different fields, and so in different packets. We tested it out, and what we found was a bug in GRO. As far as we can tell so far, we have not been able to repeat the bug yet. So I think it is way premature to make that accusation, and if you don't have direct experience with it, you really shouldn't be opening your mouth on these matters.
They don't work better rather than accurate.
Praveen Balasubramanian, Microsoft. There are also hardware implementations of LRO. So some hardware might have made assumptions about TCP options and not really handled this packet correctly.
Right. What we think we're seeing so far is a problem with hardware options potentially, which we have not seen yet, but absolutely with GRO with Linux, that there are requirements that are supposed to be followed that they're not following so far. And until we pin it down, we really didn't want to say one way or the other what the problem is. But because we have not been able to repeat it, and that's part of the problem here. So until we're able to see the problem and repeat the problem, we cannot definitively claim where the problem is. But it's definitely appears to be coalescing packets that should not be coalescing.
But I think Yuchung's point is to get the performance, they need to coalesce the packets, and if using EDO means you can't coalesce the packets, they won't get the performance that they want. So even if it was working correctly, I think that it sounds like EDO is mutually exclusive from getting the performance benefits out of GRO.
The problem is that if you want performance out of hardware acceleration and you need a new feature, then you need to have the feature supported. I mean, that's true for everything. So it is ridiculous to claim that you want hardware acceleration, but you're not going to accept a new feature if it doesn't work with the hardware acceleration. I mean, you know, change the hardware. It's not going to work on a system that doesn't support it. That's true for every option. That is true for every option.
I think that's why the fallback approach that's, you know, in the draft now is the right approach. So that if someday the hardware is upgraded, then EDO and GRO will work together happily, and until then, you know, nothing breaks.
That's part of the solution, but the other part of the solution is to recognize that the hardware acceleration may only be necessary in certain environments. What we saw was negligible change in the performance in the CPU load with the hardware acceleration turned on versus the GRO option turned on versus turned off. But what we saw was it actually worked faster with GRO off and basically pegged the meter on a gigabit interface with 2 or 3% of the CPU under load. So what that tells you is that the acceleration is not needed for end systems. It may be needed in server farms running with 10 gig interfaces or higher speed interfaces. But if you're running a server farm with those sorts of things and you expect to support new options and you want hardware acceleration, then you really need to be prepared to upgrade your hardware to support it.
Yuzhong Chen here. So just like I said, yeah, EDO will work with the slower speed ones that doesn't need hardware as a
Do you have any direct experience with EDO? Yes or no?
Sorry, could you repeat that question?
So you're talking about experience with EDO. Have you run EDO? Have you implemented EDO?
I read the draft. I know it doesn't work with GRO. Either it's a bug in GRO or it's something else. So right now the status is they don't work well together.
So the draft has a report that is a summary of a technical report. Read the technical report, which will explain it in much more detail. And what we found out was that the GRO slowed things down because the system started hiccuping and retransmitting packets. Okay, it's not that GRO made things faster even when the system was off. Even when EDO was off, GRO didn't make things faster. So the only thing we found was interference. We did not find an acceleration effect at all that was important.
I don't know how to comment that you said the GRO is slowing things down. All I know is that every time we turn it off, the TCP performance is getting a hell lot slower on high speed NIC. I don't think we need to dwell on that. I think at least the common ground here is that the offload interaction needs work, and it's already written on the slide. I'm just pointing that out.
Yeah, and this is Michael speaking. I think we don't have to discuss GRO here. So the key question is if the additional people are willing to experiment with this.
Well, it's very easy for people to throw a stick at this and complain and say, until it works, we're not going to use it. But until someone comes up with a check with cash behind it, I'm not particularly happy to hear feedback from anybody. Because what I have right now are students doing this on their own free time. And when I get students, I employ them on this project and use them as much as I can. And when I have people from Google and other companies standing up and telling me that I'm not working fast enough to give them a free solution, I really don't care.
Lim Han from Huawei. Actually, this is a very nice extension. We probably use it for different purpose. We want to use it for hardware because right now the TCP is so rigid to extend. The TCP option is completely not enough for a lot of things. So what we want, this is one of our considerations, that use this extension to do TCP signaling for hardware. We want this to be standard, actually.
Okay, that's a good comment. If you have any experience with that, we would really welcome to hear that. In particular, also if there's actual use of that. I mean, this would be excellent feedback to the working group. And if you find anything that needs to be updated, that would also be excellent feedback to the working group. I think the authors would be very willing to listen to that.
I'd be very, very
I think the people in the community has to think about the current IP status. Right now, there's no extension space in IP header. For transport, we have to have something to expand. So what else we can do if we don't have this space? Give us some option, because right now for hardware, we need something. No matter what method, tell us what we can use for signaling some. Right now, the IP was designed many years ago. They don't consider so many extension requirements.
So my proposal to move forward is maybe you can chat offline also with the authors, because this looks promising to me, if there's such an interest. So I really encourage that you talk with the authors, in particular also with Joe, and you think how this document could maybe fit to your needs. And as I said, if you consider it to implement this, even if it's a specific use case, we would highly appreciate any feedback on that. This would be really important for this working group. Okay, I guess for the moment we are not in a hurry to move forward. If in particular, also given that there seems to be some interest, I think for the moment we just keep the document in its current state. And if, for example, there is some follow-up action here, we would definitely be interested in hearing back.
Jana Ingar. It seems like there's some implementation work Joe was mentioning. How mature is this work at this point?
So Joe, you want to take that?
Can I get, okay, can you hear me? Yeah, so
Yes.
what we had was I had a student implement this, an undergraduate implement this about 2 years ago, and he's the one who tripped over the GRO bug. And he got way down into the Linux stack, and he was doing a whole bunch of things like pulling things up out of the buffers, and I'm not entirely sure that his code was correct in the sense that he was doing things that he thought was optimizing the implementation, and I'm not sure whether there's a bug in his implementation that caused an interaction with GRO, or whether GRO has a bug in it that doesn't understand these options as unknown and treat them properly. In fact, what we did was we sent back-to-back packets where we flipped a bit in the option, and we still ended up seeing coalescing. And that's flat out a bug in GRO if that's what's happening. Now, maybe he was using the interface incorrectly, maybe he was using the buffers incorrectly, and that's why we started a separate implementation last summer with some students who were volunteering, but they left in the middle of the project because they got internships. And so we're sort of back to square one. So right now, I'm having a hard time finding students who want to do this kind of work for free. If I had some support, even for the students, that would go a long way to making it happen. But that's what we're waiting on right now. The biggest problem right now is funding support for doing a reference implementation.
So thanks for that, Joe. My thought is just that we've seen like, I don't know, 10 proposals. I mean, EDO has like references to all of them, but we've been seeing proposals in the space for a very long time. It'd be good to actually have something. I agree that it'd be good to have something, but it'll be also very useful to drum up some implementation support to see if we can, even on a low burn, actually get people to start implementing this, because we've encountered this. We hit this need for MP-TCP, we hit this need in other places, and we are unlikely to not hit it. I mean, it's only going to be increasingly likely that we'll hit it again and again and again. So it'd be good to have this problem resolved. It's certainly not urgent, but we don't have to wait until it's urgent, because we know that we can't deploy anything once we get to that point.
Okay, so for the sake of time, I would suggest that we move forward.
Okay, well, I'm still Wes Eddy, and now I'm going to talk about the 793 biz document. The real quick background to try to make some time up is that we're updating RFC 793, and the intention is to only give it like a light touch editorially with as much text as we can, borrowed from other standards track documents. Go ahead. So quick history, I stole this from the data tracker, but it's been around for a while, just kind of very, very slowly moving. And we're working sort of a patch at a time into the document. So it's not like, making huge overhauls all at once. You can kind of look at the diffs between revisions and get a sense of what was done pretty easily. And there's a Git repository you can follow if you're interested. The link is there. Go ahead. So current status, I think we've rolled in all of the errata that are in the system on 793, and there are a lot. And also, I think we've gotten all of the RFC 1122 updates to TCP worked in. Several RFCs related to urgent pointer, made those updates. Initial sequence number generation. There's new content on MSS and segmentation. Talked about the ECN bits now, which were defined after 793. Incorporated a little bit of text from RFC 6529 on zero window probe condition, and added the RTO computation reference to 6298. Go ahead. So the plans to finish, can't work on this forever, and the charter milestone is set for November 2017, which is only about 6 months away. So need to start moving faster, I guess. And so I've identified sort of things that are in scope and we know still need to happen, and things that I think are a little bit out of scope that we should discuss more. So the in-scope stuff still to be done. The first two things on this list are actually in the latest update that I pushed yesterday, and we should talk about a little bit. So what I did with regard to ECN is just note the bits, ECE and CWR in the header diagram, and refer to RFC 3168 for their meanings, and didn't attempt to put in any of the directions about how the bits are set on outgoing packets and how to process them on incoming packets. I just put in a reference to the ECN RFC for that, because I think when I looked at it, it didn't make sense to try to pull that into 793. But other people's opinions are welcome there. And Gory has one.
Gory Fair has just +1 on what you said. I'm not keen on mangling RFCs together.
And the really interesting part is, so you can say those bits are defined in 3168, and that is on the standards track. So I put in a sentence, and this was the thing I think we need the most feedback on. It says you should implement ECN, and I think should was the right word, but people are welcome to debate that. With regard to the ICMP soft errors, that RFC 5461 is actually informational, and there's an interesting thing there in that RFC 1122 defines the hard and soft errors for ICMP, but it doesn't look like anyone ever defined them for ICMP v6, other than they're discussed in that informational RFC, and there's kind of a mapping there between the ICMP IPv4 status codes and the ICMP v6 status codes. So my assumption is that even though it's informational that that mapping is accepted, and those are indeed the hard and soft ICMP types for IPv6. So more eyeballs on what I did with that would be good. Everything else on the list is still yet to be done, but I think it's understood those are needed changes.
Comment from Java. It's not RFC 6161. It's supposed to be 6191.
Okay, I have fat fingers. Sorry. So you want to go to the next? So there's some things that have come up that I think are kind of out of scope if you want to consider the light touch approach that we're only copying and pasting things from standards track RFCs. So this draft GANT on the security compartment and precedence fields, that's just an internet draft that's been sitting out there, and you know, it talks about the security compartment and precedence fields, which you know, most of the code in existence isn't dealing with in the way that RFC 793 talks about. Same thing with well, sort of same thing with the next one, on the sequence number validation. So that discusses what, you know, running code has done to deal with an ambiguity, and I think both of those two might bear mention as like implementation guidance, but I guess I don't think we can put them into the spec. And then the other things on here are things that have just come up over the last couple of years, in the mailing lists, and I think that they're mostly completely out of scope because they're attempting to redefine fields in different ways, the next two at least, in ways that aren't basically compatible with the descriptions in 793. The modified Nagel one, number 5, that might fall in the same bucket as the first two, as sort of notes to implementers, because I think that describes closely what is done in Linux. And the API revising the description there seems like a tar pit. So my goal is to try to avoid that. So, the next chart, I think, summarizes what I just said about bucketing the those out of scope things in order to try to make progress on this and close on it in the next few months. So plan to kind of relegate those 3 drafts that I think discuss the running code pretty well to notes or references and like an appendix of, you know, here's some other documents that you might want to be aware of, and to basically for now ignore the other bigger changes people have brought up. Feedback on all that is welcome, and you know, the goal is to make progress and not work on this document forever. I think that's all I've got. Is there any feedback? I should thank Joe and Yu-Chung on the last few revisions. I've got good feedback from both of them on changes, so that's appreciated, and more people are welcome to give feedback too.
Yu-Chung Chen, first, I really appreciate you working on this dry document. We all know it's pretty dry, but it's very important. Yeah, so a big plus for that. So what's in your mind of, I saw your plan says complete all in scope items in the next couple revisions. And is there a sort of a timeline? I know one revision can take a year, and then.
So the charter has us in November, I think.
But to be honest, I mean, 2 comments. So the first, the charter milestone was, I think, motivated by IETF 100. So this was the discussion we had. So that would be a good date for a working group last call, but also an ambitious date, and we knew that already by that time.
It may be reasonable when you look at the list of things that we know about that are yet to be done. They're minor things at this point. I think working in RFC 1122 stuff was a huge amount of effort, was actually worse than I thought it would be. But I think that the things left on the plate still to be done are not that big.
One question is, are there, I mean, we will have to figure out how to last call this document, because it will need very critical review, that's clear. So what possibly we could think of is to partially review certain sections already. So if you think that certain sections will not be affected by the remaining changes, so, I mean, you could flag them and tell people to read at least those ones to ensure that, I mean, I'm a little bit concerned that we will look at the whole document at once and then run into issues. So it might be better to have an early thing to check things that we could flag early.
Yeah, I'll say it's only 95 pages. So it's not as bad as like any of the routing area documents. So, which,
So Eugene, do you have any concern on specific points on the draft?
I don't. So I actually I was about to make the same comment like Michael's. Like if you have a few sections that you like more eyes on it and you can flag it, then I can sort of help on that. I mean, I start going through the document, but I quickly feel sleepy because it is very dry. And so if you have a few sections, then I'm happy to help review that particular part. Another minor question is the Greg Ming show's modification of NAGO.
yes.
So I wonder what's your thought on that, consider I agree it's probably out of scope. But Linux has implemented for years, and I'm just curious, other implementation use it, or is it good idea, bad idea? I have no idea. Yeah.
Are you going to say something about that, Michael? Okay, well, I'll say about that. I looked at it and thought it was a good idea. I looked at the Linux code. It looks like it matches, and I think it bears mention, so that as an implementer, you can find it and make the decision for yourself. I don't think we would say this is the standard and you must do it, though. It doesn't fix any big problem or provide such a major benefit that it should be the new standard, right? But unless
Yeah,
the
I
working
agree.
group wants
It's
to do
a
that
minor
separately.
improvement. Yeah.
Yeah. So I think just having a mention of it and reference so people can find that.
Michael Wetzel. I'm not 100% sure if this is the right document for it, but I suppose so, because it's just an implementation hint. Some modern TCP implementations have this low watermark functionality that allows you to get some, learn define at which lower filling level of the send buffer the socket becomes writable again, so that you have better control of the data that you give to TCP. And that is not spec'd anywhere as far as I know, and it's fine to implement, right? It's within within the rules of the document to implement it, but I think it would be good to hint that this is a possible implementation or something like that.
Yeah, but the first thing, what we would like to have is, first of all, a draft for that, because I mean, adding to this document things that
This
can
is
be
just
implemented.
1-2 sentences saying that this could be configurable. It's just the
But I
way
haven't
of
looked at that
specifying the send buffer.
Yeah,
and it's not speccing anything, right? I mean, this is why people are implementing it, I think, in accordance with the IETF without even sending a draft, because you don't actually even need an RFC to do that. You can implement it either way you wish. So it's just a hint for an implementer, I think.
It's not it wouldn't be a requirement. You're just saying.
Yeah, it's completely. It's a completely sender side only. At the discretion of the implementer thing, but we don't have it described anywhere, and we will probably never have it described anywhere of a possible thing, and I think it's a valuable thing. So I believe just giving a hint about this would be useful in this.
It seems harmless to me.
Yu Chong Chen, Actually, I was about to bring up that I'm kind of on the fence because the sender buffer and also receiver buffer auto tuning are very important. But to me, it's implementation specific. It's good to have a document about it, but it's not about the core TCP protocol. If you don't implement TCP in the kernel, you can have a totally different buffering mechanism. So I'm kind of on the fence of that, and I agree maybe a sentence or two to talk about. Well, implementation might have to take care of that. Maybe doesn't hurt anyone, but putting specific details is probably belongs somewhere else.
Praveen Balasubramanian, I kind of agree that a general statement would be useful. We don't have to actually describe the algorithm, but mentioning the memory constraints and why that would be why that implementation would need to do that would be useful.
I have one remaining question. So this is Michael. On what we had earlier, the reference to the RTO, where we had it on some of the slides. We had the reference to the RTO specs.
Yeah.
So this is more a heads up to the working group, given the presentation that we have later. As if we add that, I mean, the RTO spec has a must in the abstract. And so if we add it to this RFC, it somehow nails down certain things. So that requires careful consideration, in my opinion. I'm not having any opinion myself on that, but I just as a heads up that if you reference the RTO spec in particular with a normative statement, then this has some implications.
Sure.
It could be something that we could have to review, for example.
Absolutely. Yep.
Mia Kulevin. So first of all, thank you for the work on this document. It's a lot of work. I think you're doing a great job. I think the plan is also good. As long as we put stuff in there that's already in an RFC and has IETF consensus, I don't think that's a problem. Everything that's like only a draft needs more discussion. And as such, given your plan, I'm also not worried about getting this through the process. The right expertise for this draft is in this room, so you will need some reviews, but like not too many because you didn't change any content. The content is already somewhere. It's like
At least not on purpose.
yeah, that's what I mean. We only have to double check that you do your job right. No, and I'm also sure that this document will get comments on the IETF last call and get some another feedback there. So I don't expect any problems to get this through the process.
Yeah, my suggestion to move forward is, I mean, there are some remaining things to be worked out. As sooner as this can happen, the better. And as I said, I think the group would really be willing to help you with reviews. So once you think that things can be reviewed, please let us know.
Okay.
And Gori, did you want to say something?
Yeah, but Gori first. The chairs might want to consider if they want to actually call out some sections after talking to Wes, and we could just formally kind of talk about the next IETF meeting. That would actually really get people to look at those sections and just give feedback on them.
Yeah, we could do that. But I mean, first we need, yeah, I think we need to understand which sections we really can talk about. But yes, the one option would be to have a dedicated session here for reviewing one section, for example, and going through all potential issues that might be in a given section. That would be one option, and it might be useful time here for TCPM. Okay, the next one is REC.
You could, I mean, like there are different ways to run a meeting, right? So you could even take some meeting time and split up in different groups, and everybody cares like about one section, then come back and figure out if there's a problem or not, whatever. So like you can be creative here.
Actually, my proposal was that Wes stands here and reads out every single sentence.
No, but I mean, you can actually, if you split it up in not too long sections, you can actually take meeting time for reading. Like everybody can sit down and read it, and then you have like group and they can talk about it. It's whatever. It's like you can be very creative.
We can also organize workouts on different interpretations of sentences between the groups and then see if we have consensus. But I see we will have to think about it.
Bring Just for people who find an error.
Yuchong, go ahead.
Hi everyone, Yuchong here to present the rack draft updates. So just a quick recap of what rack is, if it's first time you hear about it. The key idea is instead of the existing one that counts number of dewbacks you receive to declare you should be repairing a packet because it might be lost. The idea is simply use time because time is simply more intuitive and is more robust. And here is just a quick example on the left-hand side how rack will work. Let's say you do a TCP handshake, and after that you send two packets, P1 and P2. P1 got lost, P2 got through, so you get a SAC, which usually is also a dewback as well. In this case, you simply wait for a little bit because the packet might be a reorder. That a little bit can be adaptive, and I'm right now just being vague here, and I'll talk about more details. And then after a little while, you retransmit P1. And the intuition is simply that if you expect two packets to be delivered roughly at the same time, so minus the serialization delay, you basically add a little bit of wait time to accommodate reordering. And after that, you say, well, an RTT has passed, and I have wait for, say, a quarter of TT. It's about time to send that P1 packets. And here, right now, the implementation use a quarter of RTT, purely empirical. It could have problems, which I'll show later on. But that's the basic idea of rack that, I sent a few packets out around the same time. They should be delivered around the same time. So if one gets delivered, the other should arrive soon, right? I should expect to get a confirmation from the network, from the receiver very quickly. And if not, then it's time to retransmit. In a very high level, you can think of this as you put a timer on every packet that you sent. And that timer is dynamically adjusted based on all the most recent RTT samples. Obviously, in real implementation, this is not going to scale because you could be sending thousands of packets at the same time. You can possibly have that many timers. So rack actually implement this with just a one timer, so to speak. And that timer is actually more or less triggered by the acts instead of the actual real timer events. Next slide, please. But rack alone is not good enough. One problem is that rack still, it's called recent act. That means if you don't have any act and you have a tail loss, then you would have to do a long RTO to be safe. So here is just another example. You send 3 packets, P0, P1, P2. The first one got delivered. The last 2 gets lost, right? So in this case, the first act doesn't look anything abnormal. It's acting the first packet. So you are like, okay, I'm gonna wait for P0, P1, and P2. And typically, you want to put wait long enough. That's the RTO mechanism. IETF says you should wait at least 1 second. And then say, all right, packet has lost, let me start repair. But the idea here is that why don't you just, after in a round trip or 2, send a scout packet or a probe packet to say, let me go figure out what's going on. Just 1 packet, I'm not going to send 10 or 100. And if that packet actually solicit an ACK, that sort of means that the ACK clock is still ongoing. You just lost the last couple packets. That's why you have a tail drop. And you can quickly start repairing. You don't have to wait for a very conservative timeout and then say, look, I have waited so long and everything is lost and I have to restart the C1 from 1. So you can imagine an example, a sort of more exaggerated example is that you send 100 packet, but the last 2 packet or just the last 1 packet get lost. Without this probe mechanism, you still wait for, say, a second. Then you say, you know what? I really need to reset the C1 to 1 because that's what RFC says. And it actually delivered 99 out of 100, and you are like retracting the C1 all the way down to 1 just because the position of the drop happens at the very end. But in reality, you only lose 1 packet. So TOP is just that, okay, since we need ACK to get the ACK clock going to retransmit, I'm just getting to purposely send one more packet to get an ACK to probe that quickly. And sometimes you don't get any data, new data to send a probe packet. And in this case, we just retransmit the very last one. And that's sort of the basic idea of TOP, is that if I send a probe packet within an RTT or two, and it gets ACK back, that means the ACK clock is still ongoing. And in this case, we will perform a fast recovery instead of an RTO C-win restart.
Mark has some comment.
If it's the last packet, why do I care about the C-win?
If I hear the question is, if it's the last packet, why do I care about the C-win?
Yeah.
Is that correct?
Yeah.
So that's a great question. Yeah, if it's the last packet and C-win is reset to 1, I retransmit the last packet, loss is repaired. I think it's about sort of, I can call this collateral damage, that now you restart from C-win of 1 and then back to the SSRESH using Reno would be 50. But do you really have to reprobe the entire pass just because you lost the very last packet? And so in our rationale is that if you get an ACK within an RTT or 2, and that it's kind of like just while fast recovery only cut the C-win to SSRESH, because the ACK clock is still ongoing. You don't really need to do that.
So I would just encourage you to be a little more careful, because if it's, in fact, the last packet, then you don't have to recover the ACK clock. You don't have to slow start from 1 to 50. If it's the last packet, it's the last packet. You resend it and you're done. And if you want to do that faster, that's fine. I don't mind that part, but I find this notion that we care deeply about the C-win to be at least confusing.
Jana Iyengar, can I answer this very quickly?
Sure.
It's not the last packet in the connection, Mark. It's the last packet at the tail of a chunk of data that's being transferred. So it's basically one chunk of data.
Right.
You finish that. A tail is simply defined by not having any application data for the moment.
Yeah, so I would perhaps buy that, but you have to be a little bit more careful when you're talking about it. That's what I'm encouraging you to do.
Got it. Fair enough. I think Mark's point is that it's not the tail of the connection.
I see.
It's the tail of, yeah.
Okay, yeah, sorry. I should have be more clear about that example. There are more packets to send after this last packet of burst. Yeah.
Praveen, one quick question. So it says requires rack to trigger fast recovery. That's not necessarily true, right? You could recover based on SAC as well.
That's right. So in this simple example, you one way is you simply reduce the due-back threshold to 1 packet, and that would be good enough, right? But I'm just saying that in more complicated situations, if you are simply looking at the timing of this ACK and the probe packet and the ACK packet, then rack is used. You depends on rack to trigger all these fast recovery events. It could be a retransmit and you get ACK again. Yeah. Next slide, please. So what's new since the last IETF? So it's fully implemented in Linux 4.1. It's on by default. And right now, with that in, we replace a few previous other draft that's implemented, or RC that's implemented in Linux. It's showing up in the slide. It's just too long to go through all of them. Just listed here. But right now, Linux runs 4 major loss recovery heuristics: rack TLP, FRTO, and dupe thrash, which is essentially RC 6675. And in the -02 draft, we put some new experiment result on reordering window lengths, and also trying to see, can we run rack totally by itself without the due-back threshold on a web server. I'm going to talk about more details there, and also put some new text on how rack interacts with congestion control because there are a few comments about that being unclear. Next, please. So what we did is we on some Google servers in Western Europe, we did run this experiment for a week that we changed essentially the server to be 4 parts. One would be running RAC only. The other runs RAC plus TLP. Another one runs RAC plus TLP plus RC6675, which is the Linux default configuration. And the last one is sort of our control, which runs just RC6675. Maybe I should put more words about what RC6675 is. Essentially, it's using the dewback threshold, and the criteria to claim a packet is lost that is that you see at least 3 packets that have higher sequence have been sacked. You can implement using a byte threshold, but Linux uses the packet-based threshold. So essentially, if packet 10, you suspect packet 10 is lost, then at least you need to have 3 packets, let's say packet 11, packet 13, packet 15, that are being sacked. And that would be considered, okay, packet 10 should be lost. So the quick takeaway of this experiment is that we compare the time spent in loss recovery, total time that's recorded on the servers using that particular configuration. And found out, compared to just the RC6675, RAC alone doesn't really move the needle that much, doesn't really make the time in recovery that much faster. But when you add that with the TLP, which reduce the RTO, then the performance really shows up like in that you spend much less time in recovery. And if we say, what if I compare this to also using the RC6675, all of them at the same time? That means whoever heuristic claims that the packet is lost, it is deemed lost. There's really no much difference. So the cost here is that when you use TLP, your sort of retransmit rate slightly increased from 1.3% to 1.5%. These are all the probe traffic, because it's oftentimes on our web servers, you send a chunk and then you want to send one more probe data packet, but you don't get any new data to send. So you end up sending the very last one. And that is a retransmission by definition. And that probe traffic can actually increase the loss, the retransmit rate overall. It does not necessarily increase the loss rate, but it does increase the retransmit rate. I'm not showing up here, but our stat shows that about in our current configuration with the 2RTT probe timer, about 1/3 of them are actually spurious, meaning that you probe too early. The packet isn't really lost. It's just that the delay suddenly increased, and the 2RTT that you have is just too aggressive. But we think that the overall sort of overhead in terms of packet, additional packet, is sort of acceptable. And the really high-level takeaway is that TLP, reducing timeouts, is crucial if you want to improve the loss recovery performance. Next slide, please. Another update is how RAC really interacts with congestion control. So just a quick recap of what standard congestion control, which is Reno, says is on fast recovery, meaning that you use dewback to trigger a recovery episode, C1 will be reduced to SS thresh, and on RTO, C1 will be recessed to 1, and the SS thresh will be set to half of the the previous congestion window. So by reducing RTO, RAC plus TLP just sort of converts more RTO recovery into fast recovery, because you can think of this as having a shorter timeout, and you probe faster, and then you claim that, okay, you don't really need to go into the this whole C1 start from 1 SS slow start back to the SS thresh phase. So the rationale, just like what I mentioned, is that you only really need to reset C1 if the entire flight is lost, and also the ACK clock is lost. That means, you know, it seems severe congestion, and to be safe, you want to reprobe from the beginning.
Janai, I do. You should sit closer to the mic. The just plotting just a little bit, and this is perhaps a little bit, it's a little bit of a stretch, but is it reasonable to consider that you could keep the same C1 if you're pacing, even if you don't have an ACK clock?
So personally, I think it's reasonable, but I don't want to go there. This belongs to a whole different congestion control discussion. I just want to say that given how RAC interacts, you know, changes the RTO recovery and the fast recovery ratio, this is how they interact.
Fair enough.
But RAC shouldn't have any direct influence on how congestion control should work. Yeah.
So, Gary, first, what does ACK clock lost mean when you're not sending any data because you're not getting any ACKs?
Yeah, so I guess what RAC and TLP trying to do here is, so to answer your question directly, we think that if you send some more packets within an RTT or two and you continue to get an ACK, then the ACK clock is not lost. It's not the strictest definition of ACK clock being lost, right? That should be in one RTT. Then you see no more, you get tail drops, so you see no more ACKs. So we're losing that definition, and that's why it does have an impact on the congestion control. It indeed makes it more aggressive, you can say, yeah.
Okay, so it seems like both Jana and my questions are kind of related to the CWV thing and how you keep the flywheel moving, and but you're talking about the very, very beginning of that activity, just after you've sent a burst and not got it. So maybe we just have to be careful that we don't slip down that longer path.
That's right. So we can be more clear about this in the draft. Yeah, thank you for pointing that out. Yeah. Here is just a quick example, totally contrived. Let's say you have a C1 of 20 and you only send 10 packets, pretty common. The C1 is higher than the number of data you send in the interact sessions of TCP connection. And that 10 packets are all dropped. With the standard is that you essentially restart from C1 of 1 after a 1 second RTO. And the recovery, then you slow start, right? You know, 1 packet, 2 packet, 4 packet, and then 3 packet, because you don't need to repair more than that. So that would be 4 RTT to RTO plus 4 RTT to recover. And the C1 after the recovery ends would be 4. The very last round trip wouldn't increase the C1 because you didn't fully utilize it. That's the C1 validation draft. And compared to RAC, essentially you reduce the RTO time to 2 RTT. And then similarly, you also perform, if you're using PRR, you're also trying to slow start from a C1 1 towards SS stretch. But upon the recovery ends, you still perform what the IETF standard says, that when the fast recovery ends, C1 is reset back to 10. So this just gives you a concrete example of how this tool would influence the congestion control. And you can see that RAC plus TLP does make the congestion control more aggressive in that sense. Next slide, please. So we want to dig more into if the current draft's definition of reordering window is adequate. Right now it's simply min RTT, a quarter of min RTT, but lower bounded at 1 millisecond. Our thinking is that we need to do better work than that. For example, it could be too low if your reordering degree actually exceeds that for your reordering packets. That's say half of RTT more. Maybe it's traversing 2 different paths, and it can be more severe than that. And the sort of the consequence of you falsely claim a packet is lost is that you are going to have very high spurious retransmit in this case. On the other hand, the 1 millisecond lower bound is actually very high for data center, which the RTT is less than 100 microsecond. You can continue to lower that to a much smaller value, but the problem in data center is that you either retransmit aggressively. If you want to say, I only want to wait 5 microseconds. The current timer has the limitation, at least the kernel implementation, that you can really install a 5 microsecond timer without very high CPU cost, at least not on a large scale, right? Maybe if you want to put a lot of this fast expiring timers, that's gonna be high CPU cost. So you kind of have to make a decision. I have to wait for 1 millisecond, or I have to declare it's lost, and I'm gonna retransmit now. And the sort of the consequence could be, again, more spurious retransmit, but sort of the benefit would be a faster recovery, because 1 millisecond is say 10 round trip here. So there is all this trade-off at high reordering or very low RTT. Then you need to the current formula doesn't work well. And our idea, this is total new. We just discussed this this Monday with my coworkers and Praveen, that maybe there is a better way. Instead of this static setting, we can do a more dynamic adjustment, which measures the actual degree of reordering, but in a time unit, not the packet distance, but in time distance. And the idea here, it's very likely to be wrong, but is that you look at the time difference, the maximum time dispersion of your in-order delivery timestamp, the last in-order delivery, last packets act, and also the last out-of-order packet act, the latest SAC. And you look at the time difference, and you sort of use that as a measurement of a base of the reordering window, say twice of that, right? Let's say you measure reordering degree is about 10 microsecond, then you say, all right, I'm gonna wait for 20 microsecond. But of course, the out-of-order delivery could just mean it's actually caused by loss. So you got some halls and you got some sacks. And then you are falsely measuring this reordering degree. So you maybe want to reduce K if actually you eventually trigger recovery, and it shows that it's a pure packet loss. There is really no reordering. Or you want to increase K if some further signals suggest that your current reordering window is even too aggressive. For example, you get this spurious retransmit signal by DSAC or timestamps. And we want to sort of continue to develop this idea and then stress test this on a data center environment, and also on this severe reordering, like packet spray on 3 different paths. And the path has fairly different delays, just to see how bad rack can work.
This is Ian Sweat. Yeah, I think this is definitely an excellent idea. So we, as I think we mentioned at the lunch, we implemented a variant of this in Quick. With the math is different, but the idea of kind of an increased K if you're getting DSACs or in Quick spurious retransmits, it definitely helped reduce recovery time in cases when the core RTT was like far too long, especially for like web traffic. So.
Great. I think we'll talk offline about how the Quick does that in detail, and then.
Yeah, I'm not sure if the math of how Quick does it is the right thing, but conceptually it's very much the same.
Yeah, I really come up this last night, so I'm sure there's a problem in it. We need to further improve that. Yeah.
Praveen, just a quick comment. So less than 1 millisecond, so even less than 10 milliseconds has a cost, especially on systems that run on battery power. For example, there is a power impact. The other comment is, so my question actually is, when you say high reordering due to multipath, usually TCMP takes care of not sending the same connection over two different paths. So we don't see reorder. So my question is there any data showing that this is happening a lot?
I think the quick answer is yes. I think most of the network design will try to make TCP happy, because there has been one of the golden rules: don't reorder packet for TCP. But we are seeing a lot of signs of reordering is happening on at least our web servers. I think one very common scenario we see is that you send a burst of packet, the last one being smaller than MSS. That one gets delivered first. And then very quickly, all the rest got delivered in order. And we look into that. One explanation is that the router is doing parallel forwarding. And that little tiny packet will just, since you use less bandwidth, it gets forwarded faster in the forwarding pipeline. So it pops out quicker. And that's how the reordering happens. Typically, the router will put a reordering buffer on that just to keep things in order. But I think something is broken there, and that's why you see this a lot.
It sounds like a bug to me, because we go out of our way, even when implementing like offloads on the host, to make sure that TCP packets especially are not reordered. And then we also ensure obviously no fragmentation, so that every packet has the flow identification. So yeah.
I agree with you. Your network might not seeing it. I'm just saying I'm seeing this a lot on our networks.
Jana Iyengar, it's not on your host, right? It's on some cheap device in the network, perhaps, or some high performance device in the network. Both of those would end up doing this. One thought that came to mind when I saw this was to, second what Ian said earlier, which is, we definitely do something quite similar. One thing to keep in mind is that this doesn't show RTT anywhere in the reordering degree or reordering window. That's something that you may want to bring in here, because you don't want the reordering window to be much larger than the RTT.
Yeah, that's right. I thought about putting the RTT in the formula, but I was just trying to right now keep it simple to highlight the idea. But if your reordering is one is 1 millisecond, the other is 1 second, I think there is really no good algorithm today to cope with that other than MPTCP.
Yeah, no, there isn't. I was just pointing out that you don't want your reordering window to span multiple round trip times, because you're going to retransmit at around 1 round trip time.
Yeah, so I think we'll cap it about 1 round trip time. Yeah. Next slide, please.
Bob has some comments.
Bob,
go ahead. Disappeared.
But Bob, we didn't hear anything from you.
all right.
Okay.
Okay. So here I just want to show you a real case where, not real case, but I test this in the emulated scenario. Like I purposely create a reordering more than a quarter of RTT, just to see how bad rack can do. So this is an emulated link of with a 1 gigabits capacity, and the base RTT is 53 millisecond RTT, and I randomize the packet delay by 10 millisecond. So you said that, all right, well, that's within the 10 millisecond, less than a quarter of RTT. But the way the NetEM works is that it's minus 10 and plus 10. That means actually the reordering degree can be 20 millisecond or even more if there are queuing. So in this case, you can see that this is showing the time sequence graph, and the ACK line is the blue one. And it's very thick because the ACKs are also getting reordered. So you're getting the cumulative ACKs up and down, up and down. That's why it's drawing this big, look like a sketch. And because of that, the yellow line, the bulk yellow line is the receive window. Also is jittering a lot because the ACKs are being reordered. And what's hard to see here is actually the green line, which is in this connection runs BBR. That is completely being receiver window limited. So you see the green line kind of just tracks the receive window line there. But as BBR is doing the startup, it's doing slow start and it's gonna put more Q in it. That means that eventually the reordering degree will exceed that rack threshold of quarter of min RTT. And when that happens, rack declare all these reorder packets as being lost. And it's just shooting out all this retransmit very, very aggressively, which is essentially the pink or the red line there. And in return, it's getting all this DSACs that, hey, this is spurious retransmit, I don't need that. But BBR is pretty robust of that. Basically, you can see it continue to progress at 900 megabits per second. But the bad thing here is it's causing this spurious retransmission storm. And if we have better reordering window adaptation, we could have prevent this kind of situation. But this is just to give you a real example of when rack reordering window is inappropriate, it can cause pretty severe retransmissions. Next slide, please. So what we want to do is we want to see if rack can really replace RC6675. Right now we run both. That means when you get a SAC, the TCP queue is scanned twice in order to detect this to run both algorithms. Kind of a waste of CPU time. So we plan to do more A/B experiment by see if we can disable the dupe slash based approach on Google. And we can even do this with, even implement a dupe slash like approach in rack itself. Because if you think of that, dupe threshold approach is simply when the number of dupe ACK exceed that threshold metric number 3, you simply set reordering window to 0. That's essentially what it does. And there's no other magic about that. And you can easily implement in rack itself. So we plan to test that how this hybrid mode will work and can rack completely replace this counting approach. And next, please. So in conclusion is that this is ongoing work to make TCP resilient and efficient on both reordering and loss. We hope that we can essentially break the requirement that, okay, if you are handling TCP connection, never ever reordering the packet more than three packets. We hope that once TCP get to that point, it can enable a lot of interesting improvement, like load balancing, multi-pass, faster forwarding. The router doesn't need to put a reordering buffer at the output port, cause a lot of extra logic there. Wireless link up layer optimizations. What I mean by that would be that the wireless today Wi-Fi can bunch up a lot of packets and send, and some of them will get lost. Some of the TCP packet in that frame may not get through, and you don't have to say, all right, I need to again put a reordering buffer at the Wi-Fi host, receiving host, to make sure that I don't reorder TCP packet. Whatever that got through, you can just shoot that directly into the TCP receiver. Things like that. But in general, move the recovery into a time-based approach. And there is work to do there, experiment and ideas. And more feedbacks and ideas are very welcome. And that's it.
Okay. Paul has come back.
Hi there.
He has some comments.
Hi there. Sorry, it timed out just as I got to speak. Can you go back to slide 7, I think it was, when I tried to intervene before? It was about this, using this K, this thing you sort of thought up this week. Because I was imagining adaptive algorithms myself, then I realized networks have evolved over time. Can you hear me? Sorry.
Yes.
Yeah. Okay. Networks have evolved over time to not do any more reordering than TCP will allow them to do. So if you make TCP adapt to what the reordering in the network is adapting to what TCP is doing, and you end up just getting more and more reordering forever. So if you have an algorithm that is adapting to the level of reordering out of the network, you need to cap it at, say, 1 round trip time.
I agree with you. Right now, if you look at RAC reordering design really is today, if you allow reordering within RTT, RAC can probably do better than the dupe thresh approach. But if you reordering packet to hell, really that exceed RAC's limit, and I'm happy to be more specific on that in the draft. I mean, in the end of the day,
maybe you don't understand. What I'm saying is, if you're adapting the limit that RAC puts in to the reordering in the network over years, networks will be designed so that they can do more reordering.
Can I give some history here? This is Matt Mathis. There was a product by Juniper called an M160, which was 4 M40s strapped together that didn't do anything to prevent reordering. It was the first implementation of sharding in a switching fabric. And it went down in flames because the TCP people and actually the video codec people insisted that they shouldn't reorder. And killing this product ended up doubling the cost of the fabric because you need to do this hashing and queue selection step at the front of all of the high-speed routers. That gear ought to be unnecessary. And so it's raised the cost of the internet. I forgot what year this was. It's 15 or 20 years ago that this M160 came out. It's essentially double the cost of the internet to require this gear in all high-speed devices that would nominally be sharded. Increasing TCP's tolerance to reordering would enable saving that cost and buys us more scale, buys us another small term that we can use to beat Moore's law, because the switching fabric has to beat Moore's law. So it's very important that we improve the reordering tolerance. And yes, there is a circular independence here. The goal is to be more less sensitive to reordering and accept more reordering in the fabric.
Just a quick comment. I think what Bob is pointing out is not that reordering is not important. He's just worried that if RAC may have got this false impression that TCP is robust to any kind of reordering, and then network start reordering packets very badly, that actually hurts TCP performance beyond RAC's capability. Bob, is that your concern, right?
Yeah, like Matt said, there's a circular dependency. You know, if RAC is adapting on very short time scales, the network will still adapt on long time scales, and ultimately the two will just continue to diverge. And so I just think in your algorithm with K, as long as you cap it at some point where, you know, like 1 round trip time, where allowing reordering of more than 1 round trip time doesn't make any sense, then I think you're all right.
Okay, sure. I think we'll definitely be very specific about that in both the algorithm and the text. Yeah.
Just a clarification question. When you say over longer timescales, what do you mean, Bob?
I mean over the timescales that network equipment is designed.
Got it. Okay, that's exactly what I was thinking. So yeah, I think it's, so honestly, the fact that TCP has trouble with reordering is a problem in TCP, not the network. So that's the fact that we end up being dependent on receive order for doing loss detection and recovery is closely tied to TCP performance. And all of that is a side effect of the fact that we assume that packets are more or less being received in order. Mark's in the audience somewhere, so he can, you know, the data for basically using 3 as the rule of thumb was based on data that we saw about how much reordering existed in the network. What Matt was pointing out is exactly right. I think that if we can move away completely from this notion of having to use one path, having to use one sequencing through the network for a TCP flow, you end up getting much better higher order properties where you can utilize the network much more efficiently. You're not pinning flows, and therefore you're distributing packets evenly across the network and all kinds of fun stuff. We aren't going there, but if you're talking about heading in that direction, I think it's a good thing overall.
Yeah.
By the way,
I'm not saying it's not a good thing. I really like rack. I'm just saying, just make sure you don't create a circular feedback loop and get a high whistle in 2 years' time.
But it sounds like the feedback loop you want, Bob. But that's it. I was just going to say that I think this is a classic case of where L4S would be useful. You're talking here, your voice is coming here first, and your video is coming almost 3 seconds later. Right. So, anyways.
Michael Wurzel, I got in line to give a +1 to what Matt said, but I think Jana just did that, so I'll just say +1.
Thank you.
I was actually going to add one more sentence. The natural case is to assume that each packet has an independent delay distribution, has nothing to do with packets ahead of it, as though every packet goes into its own queue, and that's constrained to as though all the paths are the same.
So this is Michael speaking. I think this is a very interesting discussion, but still, I mean, this is an experimental document, and I think there's some need for experimentation in that sense as well, because if we relax the constraints on how network equipment could work, I mean, this is something that affects other areas in the IETF. So I think this is correct, but this is probably exactly a reason why we need experimentation, because there's probably BCPs that talk about reordering and things like this. But this doesn't limit us from doing anything here. Okay. It's just we have to be a little bit careful with how we talk about it.
Okay.
Okay, for the sake of time, let's move forward. And the next one is I don't recall. Is it Corey or Michael? Mike. Oh.
Thanks, Michael. Do you want to add that sentence into Etherpad, or I'll add it after my talk? Okay. Oh, great. Yeah, this is the shortest presentation ever done at the IETF. The first reason for standing here is to say, hey, this document was adopted by the working group. Please read it. The things we did in the last update was simply to describe the nature of the experiment, which had become defined in TSVWG. The number of currently pending edits is 0, which means please comment. Next slide. And we don't intend to change it. We tend to ask for the progression to working group last call unless people comment, so please comment. What we'll do in the meantime, though, is we'll implement that we already have patches available for Linux. It's old, so we'll update the patch. We also have a patch available for FreeBSD. It's old, we'll update it, but we'll also try and get the FreeBSD into mainline as an option. These are both planned for Prague. Anyone else want to implement? Anyone else want to comment? Someone say something. The title slide. Yeah, this is the best slide.
The wrong person is on the line here. Michael Wurzel, just as a call, I'll just state that this is very, very easy to implement. So if anybody is interested in experimenting, this is an easy experiment to do.
Yeah, and we'll easily give them the patch code, which is a few lines. No, I can mimic him. I'm trying. I'll go before I get hit.
Okay. Thanks, Corey or Michael, whoever you are. I think this is a very short document, so if there are no comments on that, at some point in time we will probably move it forward.
Marco, you want to say something?
Yep. Can you hear me?
Yep. Hi, Mark.
Howdy. All right, you ready?
So the next one is Mark. Can you talk?
Yeah, I can talk. I'm really good at that. Can you hear me?
You might be too close to the mic. Your voice is very bad.
My voice is very bad.
Mark, it's Tim Shepard here. It sounds like your voice is clipping, like way too much gain before the codec on your end. Maybe further away from the microphone or speak more quietly might be better. I hope that.
All right, wait a minute. Does this work? Does this help a little?
Yes, it's better.
Okay.
Yeah, that's better. It's still clipping. Even more would be good.
Something like that.
Okay, go ahead.
Yeah, that's sounding great now.
Okay. Thanks, Tim. Nobody has ever said I sound great. So let's see. I wanted to talk about this RTO consider draft for a minute. You can go to the next slide here. There's the name of the draft. Started this a very long time ago with the notion of relaxing TCP's RTO algorithm. I think that we all sort of know that reality has lots of implementations doing lots of things that don't exactly follow 6298. And somehow the internet is still working. So this was an effort to say that's okay if you do things that aren't exactly 6298. All right, what we're going to do is we're going to give some requirements that are important, but we'll give you some wiggle room on the things that aren't quite as important. Okay. All right, so let's go to the next slide. Yeah, so this has been done within Tcpm, and the status with respect to the TCP, I think, is pretty clear. I think we've got fairly strong consensus for this document. I think it's been there for a long time. I don't think there's been much comment, discussion, angst about the technical meat of this with respect to TCP for a while. And if there has been, nobody's bothered to tell me about it. So that's where sort of we are right now with TCP. But as I was thinking about this, I was thinking, well, of course, this, yeah, exactly. Next slide. So this sort of naturally applies to SCTP, since SCTP and TCP have a sort of highly similar RTO. And, you know, so then, you know, my pea-brain got thinking even more that this is actually pretty general requirements for an RTO. And so I started thinking, like, where would I not want to apply these general guidelines? So I hacked out a version of the draft that sort of divorces it from any sort of TCP specifics. At least I hope I've done that. If there's a place I haven't, that's an oversight. So it's actually quite a broad document now, and it talks about the setting a retransmission timer for whatever protocol you want to use. Still applicable to TCP, but not specific to TCP anymore. So let's go to the next slide. I don't remember what the next slide is. Hello?
Yeah, it's already on. I'm on the next slide.
I don't see it. Okay, so this is, oh, now I do, okay. Yeah, okay, so my thing wasn't updating here. So the document, also, another little bit of history, this is sort of an abbreviated history. which I know Michael and Gory will appreciate. The requirements, the guidelines in the document sort of formed a very small subset of, or a sub-et apparently, of the UDP guidelines RFC, in which, in the places it talked about a retransmission timeout. And to a large extent, the UDP guidelines and the RTO consider agree. Like almost completely they agree in what they call for in a normative sense. The exception to this is for exponential backoff. So RFC 8085 does not call for exponential backoff, or if it does, I overlooked it. And RTO consider does. I reviewed 8085 when it was a draft quite a bit for RTO stuff, and I don't remember all the details, but I'm kind of annoyed that I didn't figure this out and flag that there was no call for exponential backoff. But that's sort of the only place I can find where these two documents really disagree. So I think that for the most part, the RTO consider guidelines apply to UDP as well as TCP and SCTP and anything else I can really think of. So, okay, let's try this again. Let's go to the next slide and see if, there we go. Okay. So the quick overview of the draft, it's like 9 pages long or something. It's very easy to read, which is, why we fight about it so much, I think. I should make it 95 pages like Wes's draft. So these are sort of the normative things that RTO consider says. I think these are pretty non-controversial. They come from other places for the most part. So it says that the initial RTO must be at least a second. That comes from 6298. The RTO should be based on recent measurements of the feedback time, how long it takes to get feedback that something has arrived. The RTO should be based on regular measurements of the feedback time, where sort of the guidance in the document says regular should sort of be defined as, like once per round trip time or as often as you send data. But this is a should, and the definition isn't meant to be sort of hard and fast. Just that we shouldn't just take one sample of the feedback time and call it good for all of time. Let's see. The next one is that we can. No, not the next slide. Next slide. This is really screwing me up here. All right. No, not that slide. One back. Slide 6. All right. Next remote presentation, I'm going to get a better driver. So let's see. I don't even know where the hell I was. Yeah. So it's okay. So the feedback time may be measured with non-data packets. All right. So that's like a heartbeat or something. Doesn't exactly have to be a data carrying packet. The last bullet here just says use Karn's algorithm. So ambiguous samples must not be used when you figure the RTO. All right, now I really do want to go to the next slide. Yes, it says exponential backoff must be used for repeated retransmissions. I think this is a network safety thing. And then there's a couple sort of subpoints here, which is that exponential backoff should be canceled after we repair a loss. That's pretty standard stuff. We say a maximum RTO can be applied, may be applied, but must not be less than 60 seconds. That comes right from 6298. I really don't know where the hell 60 seconds comes from. It's like, old tradition, folklore, I don't know. But it's a pretty big maximum. So, The final bullet says that if you retransmit something based on the RTO, you must take that as a sign of congestion. That's pretty standard stuff. And so then you must do something to respond to that congestion, something sort of standard, right? We don't specify what. You just have to go off and do something standard. So that's the sort of very nickel tour of the document. I don't think any of those things are particularly controversial. You can go to the next slide, whatever that is. Yeah, so the most recent rev of the document changed a couple of the musts that were in there to shoulds to kind of sync it up with the UDP guidelines. This was in the area of things like you should take samples regularly, things like that. Instead of saying must, we say should. Nothing, particularly great here. You can go to the next slide. There's more slides than there are pages in this thing, which is ridiculous. All right, so this is, I think, the plan that sort of the ADs, the chairs, I agree on. We need to get some feedback from non-TCP folks. Michael Tuxen already sent some SCTP feedback, and that was great. There's a few things, it was on the list, there's a few things I'll roll into a rev of the document. When it's time to do a working group last call, I think everybody sort of agreed that we can just keep it in this working group because this is where it came from. But this is also, if this is to be broader than TCP, and it seems like it's at least broader in the fact that it applies to SCTP, that we should also run the working group last call in the transport area working group. More reviewing is better. So I think there's one more slide, isn't there? Yeah, so the part of the plan that I guess we need some feedback on is, sort of how broad do we want to scope this? Again, I sort of look at these guidelines and say, well, where would I want these to not apply? I think they apply to TCP. We have consensus on that, I believe. I think they apply to SCTP sort of by extension. And I think we know that they apply to UDP because of what's in the guidelines RFC. So I think the sort of general game plan that we've come up with, and I'm attributing this to Mirja, but she may state this a little differently than I would, is that we should just leave this document as sort of writing down our best advice, what we know best about how to construct an RTO, and we'll just trust the implementers to figure out where this applies and where it doesn't apply, and sort of leave it at that. Instead of some versions of this document have had very explicit statements about where this applies, where this doesn't apply, things like that. There's some scope statements still in there, but largely have removed some of these statements about where things, what can use it and what can't use it. I think that the notion that implementers can take sort of our best advice and use it is probably the right path forward. And that's my last slide, isn't it, Michael?
Yeah, thanks. And then we have 3 people in front of the mic, so
yeah, of course, So go ahead.
Mark, Jana Iyengar here.
Yeah.
See, this is why it would have been a lot easier if you were actually here. A higher order point and a more specific question. I'll ask the specific question, but you can answer it later. But I really want to focus on the higher point. The specific question is: you have the min of 1 second for initial RTO.
No.
And
well,
you do in the doc. Initial RTO must be at least 1 second.
You just
not min. Sorry, apologies.
Yeah.
Yeah,
so
sorry.
let's be very careful. You said 2 things. So the document and what I said, there's no min RTO, but there is an initial RTO. Before we know anything about the path, We need some sort of timeout, and that initial RTO.
Yeah, I agree.
Right. So no, I know.
Spoke when I said.
Right. I just want to make sure we're clear on that. So go ahead.
Got it. Yeah. With you. I think this could be reconsidered, but we don't have to spend time on this now, and we can talk about it. I'd certainly like to make the initial RTO much smaller. There are conditions under which you have reasons to believe that you know what the RTT might be. For instance, you have a TFO cookie which encodes the RTT, for example, from the last connection. There are conditions under which the initial RTO could be smaller. I will not rat hole on this. I'm going to step out of this issue. But the bigger issue, I think, which is more interesting to me, is as I was looking at the draft, the other transport you didn't mention is quick. And all of this applies wonderfully to. I love this document, by the way, because it's exactly how I think about RTO. It's not the precise exact numbers, but it's make sure that the spirit of RTO is captured right and well.
Right.
The point though is that as I've been thinking about, for writing loss recovery for quick, one of the things that keeps coming back to me again and again is that it's not necessarily a retransmission timeout. It's something like a congestion timeout. There's a difference between. So the RTO captures two things, right? One of them is the actual retransmission, which is the recovery part of it. The other is the detection. This is the network safety part where you're backing off. There is no reason that this document has to combine those two things. I think that this applies broadly to the idea that I've not received any feedback, and therefore my packets might be going into a congested network, and I should now back off my rate. I may not send the same packet again, but I should do exactly those things still, which makes this not an RTO. This is one of my struggles. I'm trying to write out RTO in Quick, for example, but it is not actually RTO. It's something else. Yeah.
Yeah. So can I?
So
let me give me a minute, Matt.
I was going to add something scary to that.
Right.
It actually applies at all layers everywhere.
Okay, so
Mark, sorry, just one last thing. In Ledbat, Media and I actually coined the term congestion timeout for exactly this reason. But go on, your turn.
So yeah, I don't really, in particular, disagree with anything you've said. That this is that you could use, this timeout for different things. I think that I guess what I'm thinking is that I would not like to. So I would like to see this document get finished sometime. I think that would be great. And
yeah.
And so
fair enough, but the document.
Well, no, I just think that if you sort of increase the scope of this to say congestion timeout. I'm just not entirely sure. I agree with your general principle there, and I agree with how you're thinking about this, but I'm just not entirely sure that we understand that notion as well as we understand. I just have a packet here that I need to deliver reliably, and one of my techniques is to use a timeout. And so here's some guidelines for doing that. I think that's at this point pretty well understood, and I'm not sure we're quite there with something like a congestion timeout. And so
I'm not. I mean, I agree with you that TCP surely there's nothing in there for us to reconsider this. I don't think this idea is particularly is that far out from where we are right now. I could literally, the document as it is applies pretty much entirely to the idea of a CTO. But we don't have to call it a congestion timeout. But I'm just saying that you could remove all of the retransmission pieces from here, and just stick with loss detection, and that would still capture everything that the document has as its core. Now, I appreciate the wanting to get this finished. It's a thought, of course, because I see this and I go, this is beautiful. I would like to reference this instead of 6298.
Me too.
Yeah. So that'll help me do that. Meaning that if I can separate the idea of retransmission timeout, retransmissions from the idea of a timeout, then that would really help quite a bit.
So let me let me just say that I think it's a fair point. So let me just play this back and make sure I understand what you're saying. You're saying that if we took out the words retransmission and just said this amount of time is to detect loss, whether or not we retransmit, whatever, we just detect loss, and loss can be used for whatever, triggering retransmissions,
It's actually similar.
doing congestion, whatever, then you would be happy. And is that basically what you're saying?
That's roughly what I'm. Yes,
Okay.
that's roughly what I'm saying. I can go through the doc and make sure
Yeah.
that I can lay it out for you like more. But I think Matt wants to add something. But
Yeah.
I
So-
think that's what I said. Yes.
Okay, so just my high order response to that is, okay, I think that's something that we could consider. Okay, and I don't want to, I guess, I sort of need some quiet thinking time on that. So go ahead, Matt.
So it sort of simplifies down to you want to present exponentially decreasing load in the absence of feedback. And it sort of is a general statement. And this, in fact, applies at all layers. And so there's, for instance, known pathologies between things like the VGP heartbeat, which is linearly spaced, and TCP's exponential backoff. And people have argued that this is a bug, but it's never been written down. I suspect that this document actually applies at all layers in all applications and all protocols. Or a slightly different version of it. And the issue, like I just reworded, is that you want to make sure that if you're not getting feedback, you present an exponentially decreasing load.
Right.
That's the key property.
Yeah, and that's the one that I think I missed in the UDP doc, and that stinks.
And for instance, UDP can cause congestion, or excuse me, DNS can cause congestion collapse under pathological conditions.
Sure, of course.
Ian Sweat, Google. One clarifying question. When you said that there must be a congestion response as a result of a RTO, does that factor in, or is there any wording? I haven't read the draft, I apologize, for FRTO where you find out later that the congestion response is spurious? Okay.
Yeah, there is. There's words in there that say exactly that.
Cool. Okay. Thank you. Sorry.
Yuchong Chen here. So Mark, I want to ask you, let's say if I don't do exponential backoff for the first 2 retries, I do the linear backoff, then switch to exponential backoff.
Yep.
Do you think I will violate this RFC?
Yeah, so I don't know. I mean, beats the hell out of me. I had this discussion with somebody, and it might have been Yana. I tried to not nail down some of the, what does exponential backoff mean? But, does that does it have to be 2 times the RTO? Could it be 1.95 times the RTO? Could you, skip the first one? I don't know. I mean, to me, the spirit of it is that long term, there's exponential backoff. Like Matt said, we want the load to drop off exponentially. If you cheat and don't do it for a round trip, for the first one or the second one or whatever, I don't know. I mean, I'm not going to get too upset about it, but I don't know. Somebody might have a stricter reading of it than says, yeah, you wouldn't be. I don't know. I'm trying not to get into the details.
So since
that's kind of the point of the
since
draft.
this document is about wiggle rooms, that's why I'm trying to get the wiggle room here for the exponential backoff. I don't know if changing it to eventual exponential backoff with a high exponent is.
There's sort of sort of wiggle room, and then there's wiggle room, right? I mean, I don't want to say eventual because somebody's going to say, well, if this lasts for 3 days, I'll eventually get to multiplying by 2 or something. I don't want to give that much wiggle room, but I don't know exactly what words to use to say, Ken's okay if he wants to cheat for 2 retransmissions. I don't know.
But I think what we really trying to sort of point out is that we believe exponential backoff is critical for network safety. And I think that word is being spelled out right now. I'm just, all right, I don't want to do all of this, but I think you kind of answered my question already.
That's as close as I ever get, kind of. Gory.
Hi, Mark.
Yeah.
Gory Fairhurst. So I think 8085 meant to say that. The problem with UDP is there's so many different ways to express what you might want to do. But for at least one class of application, it says it. And for the other ones, it says use TFRC and other standard methods for the congestion control. So I don't think anyone should doubt that 8085 intended that if you've got a bulky like application over UDP, you should do the exponential backoff.
Fair enough.
I'm just trying to say that is exactly what the authors intended.
Fair enough.
Hi, Mark. Tim Shepard. The conversation over the last couple of minutes just made me realize that we could obsess over what the right thing to put here is, but we haven't. I don't think you, and I don't think we have said anything about how many TCP connections an application may attempt to start in any period of time. So an application that attempts to open 10,000 new TCP connections over the course of a second will generate 10,000 send packets that get injected into the net. And I don't think we have anything in current operating systems, or I don't think there's anything in recommendations that, prohibits that or anything in some sense.
Yeah, so
we shouldn't obsess too much about this.
So I would suggest
I don't think we have.
I would suggest that that's out of scope for this document, and I would nominate you to write that document.
Oh no, I don't. I just think I don't think we need another document. I think we just shouldn't obsess too much about any of this.
Yeah,
And I think you said something earlier.
It's a fair
about
point.
We trust people to think and do the right thing, and that's just, there's no getting around the need for that. I think you said that earlier in your talk, and might even have been on one of your slides.
It is.
I forget which. I don't know.
The last slide.
Yeah. So I think that's, in some sense, that's the key these days. And and this is similar to the discussion where we went round and round about, well, what should we do for the internet? And I think was this TSV WG or TSV area where we talked about where we had that half-hour discussion about.
Yeah, we only have a half an hour left, so that's why we are running out of time.
So we shouldn't worry too much. So.
Jim Roskind. I've been thinking about exponential backoff in another context, and it's sort of an interesting, humorous thing. I think it's really the wrong thing to think about here. Exponential backoff, like historically with like CDMA, worked well when everyone could look and see that a channel was being blasted. But you have this idea that someone wants to send a request, and if everyone in the world decided to send a request and they're all allowed to send one more request when it doesn't make it, just one, forget about how long the exponential backoff, you've just caused actual demand of one to create effective demand of two around the world. And I don't think that's how you have this congestion collapse. So it's sort of interesting that when you get down to a single item being sending whether it's one or two or three requests, then finally actually giving up, still generates 4 times the effective load around the world. So I think there's something more interesting to say about aggregating. So for instance, if you lost 50 packets, I think it's much more important to say something about not retransmitting 50 packets and only transmitting maybe one until you see that life is good. That seems much more important, because that only adds 2% additional load to the world under a bad situation, as opposed to, well, I got 50 packets, but I'm only allowed to send them all one extra time before I wait an extra second. You've now really congested the world. So it's sort of interesting when you get down to a single person or a single packet. I think exponential backoff is the wrong term, and you're noticing that because you're not sure about what the base is in that exponent. At least this is my perspective, unless I'm missing the problem. The fundamental problem is changing actual demand. Okay, you want to answer, Mark? Am I saying something strange?
Yeah, but we are really short on time, so please keep this short.
Yeah, I mean, I'll just say that this document says sort of, you set an RTO to find some loss, then do something standard, right? So, you know, if you go look at 5681 or something, that tells you if you lose 50 packets, you don't get to send 50 more right away, right? Eventually, you can recover your 50 packet losses, but you don't get to do that right away. So, I mean, I buy what you're saying, but I just think it's sort of out of scope for this particular document because this document isn't meant to really generate or define a congestion response per se.
Yeah, I have to cut off the line
The,
here.
the sort of question had to do with a UDP request and when should you retransmit a single lone packet?
Yeah, it's fair
And
enough.
I think
Fair
that's
enough.
where it's very applicable.
Yep.
So we have to move forward. That one on the, I think what I hear from the room here, there's first of all, there is some comments on the actual technical comments and on the wording specifically. So this probably warrants some thinking. What we also hear here is that, I mean, some of the guidelines might not be really fully agreed upon. So that's why we definitely have to think about if this document really can be published as a BCP. So because, I mean, there are certain parts of it that are clearly, there's consensus on that, but there are also certain things where you might have to consider if it's really worthwhile to do this as a BCP. Because at least the ambition to publish this fast could be achieved, for example, also by an informational document. But I'm taking this to list to leave room for these remaining presentations.
There is no way this document will be published fast.
Well, then, let's be clear. I mean, we want to finish this work, and we have to find a way to finish it relatively soon. In my opinion, and as I said, the one way of achieving this is I think clearly stating maybe things that it won't do, and for example, not updating 8085 would be one option.
We are not updating, are we? We are not.
I think we're consistent with 8085. I don't see, we don't. Why completely consistent. I mean, based on what Gory just told us, we're completely consistent with 8085.
Yeah, then no need to update if it just says the same. Actually, I think my sense from the room was a little bit different. I think we had like broad agreement on the normative guidance in this document.
Yep.
I don't think that any discussion that happened will change the normative guidance of this document. It's really more editorial changes. And as such, I think we can move forward very quickly. And on the BCP question, I don't see anything in this room that would forbid to support BCP or whatever. But like, I would just leave it to the last call. And if people come up in the last call and say this should not be BCP, then we can discuss it again. But other than that, I think from this group, I heard like large agreement, and we are ready to.
Okay, maybe I should add as individual. I disagree with some of the shoulds for TCP, but I can put this to the list.
Okay, so just a little bit of procedural thing, and I'm being very, very quick. If it goes through as BCP in TSVWG, then we'd expect to be checked against all of the BCPs and PSs, which is a lot more painful last call than an informational where there is strong consensus to publish the informational document. So maybe we just need to bear that in mind as we go forward.
Just quickly add a comment that if this is going up to TSVWG and it's broader than TCP, then we should talk about it with regard to how it applies to Quick. And I think I'd be happy to help with that in terms of text or in terms of thinking or whatever it is. I don't think this will take a lot of time.
Great.
Okay, Michael.
I'm in the box. All right, 2140 bis update. I'll make this short and you will make it long. Next slide, please. Yeah, so we addressed the comments that we got, we believe. There was a comment from Yuchong and also Jana about correctly reflecting the way Linux shares old RTT. I think we did that. There was a comment from Yuchong about the granularity of sharing, basically the fact that relying on the IP address as an indicator can be misleading. And you have other indicators like HTTP cookies might be a better way of figuring out what an endpoint is. So we have text about that, and that was, I guess, one of the more important changes here. There was a request from Jana and Lars and maybe even a few others to say that the table should be divided such that it's clear what is really safe to share and what is not. Rather than dividing just for the sake of being short and concise here, we added a column which says safe, yes, no, TBD. So next slide, please. Other changes, we clarified that the OS implementation overview that we have in, I think, in the appendix only covers temporal sharing. There is old TCP text that has historic value, and for that, it is in the appendix. This was a bit complicated, and I'm thankful to Joe for taking care of this one. MSS has been split into existing terms from RFC 1122, MMSS, MMSR, because these are different things on the sender and receiver side. We fixed the use of MSS and MTU. We added information about option sharing. All the options are listed in the appendix, and basically now it says for these, nothing should be shared. Next slide. So the request here is to get this adopted, and the suggestion on behalf of the authors is that we would like to aim at BCP, but we also don't think that this is a decision that has to happen before the document gets adopted. With the idea being that aiming for BCP means that the discussion in the working group, once this is adopted, could be along the lines of what needs to be done to the document to make it BCP able and BCP capable. I don't know what. And if we will never agree on that, then it should be informational. But as long as we find a way to agree on it, it could be published as BCP. That's our suggestion.
Yeah, and this is Michael speaking. We would specifically be interested in hearing feedback from the group on the latter part. Assuming, we will run an adoption call in a second, but assuming that we adopted, are there any opinions on the suggestion of the authors, whether this should head towards a BCP or an information? I have to say that, of course, we can revise that question in either direction later in the process.
Yeah, Kulevin, can you explain a little bit more why you think BCP is the right thing?
Can I explain why BCP is
the right thing? Or do you think BCP? What do you think?
Yeah. We document best current practice in the document. That's why. So it's all based on stuff that's implemented for a long time. Some things are being shared. There's a lot of advice there about what is not being shared, because RFC 2140 suggests it might be shared, and actually it really shouldn't be. And then some things are relatively openly discussed, and they're not declared as being safe to share. There may be some text updates to move some things, to kind of divide the document into a part that specifies a BCP and discusses some other things, but everything that we declare as safe to share or known as not safe to share is based on many years of experience from different OSs.
So my personal opinion, given that the implementation do the right thing anyway, it doesn't really matter for me what the status is of this document.
Okay.
Okay, first of
all. So it means it's fine with you. It doesn't matter.
Well, anyway, as I said, I mean, we will not make a final call on the status right now. We will do an adoption call, but not. I mean, this will have to be reviewed in the last call anyway. So that's what we usually do. So, are there any other comments on first of all the technical content of the document? Then may I ask, show of hands, as how many of you have read this document? So for the note takers, this is 3, 4, 5, I would say. And this is at the very low end. Okay, Yeah, okay. I will. As
more
five
than
people is not a lot, to be honest. We will have to take this to the mailing list anyway. But for at least to check the sense in the room of the people who have read the document, how many believe that this should would be okay to be adopted as a working group item? So I see 1, 2. 3, more or less most of the people that have read it. Is there anybody here in the room who thinks that this is, for example, not ready to be adopted? So, okay, there are no concerns on that. So we will have to take this to the list because the feedback is relatively limited. But we will follow up on the mailing list. There's no clear sense in the room, I would say. There's also no disagreement with adoption. So we will look for additional feedback on the mailing list and see what we can do.
Mayor Kulevin. So maybe you should ask one more question because I didn't really read the document, but I know what it's talking about. I think we should update the original RFC, but like as I didn't read it, so I can't tell you anything about the wording of the document, but I think this working group should work on it. So it's as such. You can
okay.
actually...
The general question is, okay, I missed that one. So how many in the room believe that this is generally something that requires work by TCPM? So that's the easy question. That require, or that way work in TCPM would be useful, generally, the area. Okay, so these are at least 10 or of the order of 10. So this is more. So there's clearly interest in the working group, but we will have to follow up on the document and how we exactly proceed. Okay, then we have Jonathan.
I am Jonathan Looney. Here to talk to you about 64-bit sequence numbers, which will take an hour, but try to stick it in 10 minutes. Actually, I'll only take 10 minutes. You can make it longer. So next slide. So the problem that we seem to be having is that high-performance networking is changing life. And I think this was highlighted at Seoul when we had 2 proposals that came. One was to make larger window sizes, make the maximum window size 2 to the 31st, I believe. And also higher precision timestamps down to the nanosecond level. When you combine those 2 things together on a high-speed network, you get in a situation where you can have a lot of data outstanding in the wire, and you may not exactly be able to be 100% sure whether or not it's a packet that is an old retransmission or new data that you need. And so how do we safely support high-speed networks? Next slide, please. So some assumptions, thinking about the problem, some assumptions are that, first of all, TCP-NG, or whatever the next rev of TCP is probably a non-starter. So whatever we do to solve this should be backwards compatible. If you do want TCP-NG, I think the Quick Working Group is meeting tomorrow. And that's a chance to rethink some of these things if you want a brand new protocol. I think we'll probably need, my personal opinion, and my forecast is as good as anyone else's, is that we'll need 64-bit sequence numbers in about 10 years. My forecast is as good as anyone else's. The fact is that networks keep getting faster and faster, and we need to be able to support that. And my general opinion is it takes about 10 years to roll out major TCP changes. So from now until it actually made it out into the network, it would probably be around 10 years, give or take. That's my personal opinion. Again, my opinion's as good as anyone else's in that matter, I guess. Next slide. So the proposed solution is to actually use 64-bit sequence numbers. So we can keep the lower 32 bits in the current sequence number fields. So they'll continue to increase like they do today and wrap like they do today. So if you're just looking at the TCP header, the sequence numbers will look the same, but you take the upper 32 bits and stick them in an option. The goal is to generally try to leave the TCP frames looking the same and make TCP generally work the same from the perspective of middle boxes or other things that are looking at the packets. And then obviously to make this work, you have to provide some sort of automatic negotiation on session startup and backwards compatibility for hosts that only understand 32-bit sequence numbers. And there's the draft has mechanisms to do that. They're not perfect, but there's a start to the mechanisms there to do that. Next slide, please. So what in the world are you thinking? In theory, that sounds like a really simple solution, right? But how long have we had 32-bit sequence numbers? Like 35 or more years. There's a lot of assumptions in RFCs, implementations, et cetera, that need to be updated if you update the size of the sequence numbers. And by the way, just what option space are we going to shove this into? So we would need, potentially this would push along the need for the EDO draft to be standardized. So in general, this is non-trivial, and it's something that is not to be undertaken lightly. It's going to take a lot of work, both from us as a standards group and also implementers to implement this correctly. Next slide, please. But I really do think we need something like this, and the time to start thinking about this is now, rather than when we suddenly realize that TCP is not able to perform fast enough on high-speed networks. Because of the long lead time in getting features out the door, I think we need to start thinking about this on the earlier side. My general opinion is that this is a workable approach. I don't think it's perfect. I'll readily admit that there are details that need to be filled in, and there are things that need to be considered and thought through. And there may be other better approaches too. But I think we need to begin thinking about how we are going to be able to support higher speed networks. And I think 64-bit sequence numbers probably is the way forward on that. So the general request for today, I'm not asking you to adopt the draft, just my general request for today is if you have feedback on this, I'd appreciate hearing it. My email address is on the draft. Feel free to send me an email. Let me know whether you think this is something that is worth putting more time and effort into. Let's see if we can get some consensus on whether this is something we should be pursuing or not.
We have time for one or two questions.
I noticed the draft does not reference RFC 1263. Are you familiar with that document?
Can you give me the title of RFC 1263?
TCP options considered harmful. And it actually proposed changing the format of the TCP header to have 64-byte sequence numbers, 64-bit sequence numbers. And there was actually, this was 25 years ago, actually. I looked at the date, 26 years ago. And there was a considerable amount of discussion at that point about the difficulties of negotiating a different protocol number, because that was the approach that they were basically taking. A lot of those problems have been revisited in, I'll say, in the quick space. Mm-hmm. And if you're going to change it becomes the same problem as deploying quick. It's essentially the same problem. You can change the header format. If you change the header format, you can do all sorts of new and different things and reimagine stuff.
Right.
And fix other things that are cast into the current TCP header.
Right.
But at that point, you're sort of you're re-following the same path that the quick people followed.
Right. So. Yep.
Hi. So I was wondering how you are going to avoid the same GRO problem that we already talked about at length for EDO, since it's for high performance environments, and we know that GRO is the problem there at the moment.
It seems to me that the answer is essentially what Joe said earlier, which is if you want high performance networks, have your hardware vendor put it into your hardware.
Okay, one last comment because we want to have time for that. Yeah, go ahead, but that's the last comment.
Yucheng Chang, I'll make it quick. That's why I think we really need TCPM or IETF needs to document GRO and TSO because there is no spec. So everybody plays their own rules and just roughly test if TCP cubic today works well or not. And that's this really is the source of all these problems. Yeah.
Okay, thanks. I mean, this is good for triggering hallway discussions and things. I'm just okay, but Joe, 1 minute.
Yeah, all I wanted to say is that the big trick with GRO is twofold. Number one, it absolutely needs to follow the TCP spec. So if it sees an option it doesn't understand, it needs to not mess with it. And that's what we're seeing, and that's what's causing the problems right now, at least in the preliminary stuff that we've seen. In terms of speeding things up, there's always this problem that you can't speed up something you don't know about. So it will never be the case that hardware will accelerate options it isn't programmed to deal with. There's never a way to get around that.
Okay, so with this, I think we go to the last presentation. This is Praveen. And by the way, if you haven't signed the blue sheets, then please do so. Yeah.
Hi, Praveen. This is a similar talk to one that I gave last year in the Berlin IETF, mostly talking about implementation experience, as well as the more recent updates to TCP in the Windows networking stack. This also kind of shows that the work we do here in this community impacts real products, bringing performance improvements to large amount of users. So this is a quick recap from last time. The first big update to Windows 7 was the anniversary update, which is the one that contained more of the recent changes to the TCP stack. We have a server product, Server 2016, which was also released late last year, which also has all of these features. The list is tail loss probe. It's only enabled by default for when the RTT is greater than 10 milliseconds. This is the same concern that I brought up earlier about low resolution timers having a power impact. Recent acknowledgement rack, which Yucheng presented previously, is also enabled by default only when the RTT is greater than 10 milliseconds. IW10 has been enabled by default. We are not seeing a significant difference between IW4 and IW10 in terms of losses in the initial window of data. Initial window is not paged in Windows. We still don't see too many losses due to the initial burst. Fast open was until recently available only as an experimental feature, so the user had to opt in. And the last one was LEDBAT, which is only being used for internal workloads at this point. We do plan to open it up for other applications by making it a public API. This is mostly for like background downloads or uploads. Looking forward, there's a Windows 10 creators update. This is going to be a free update again, so it should hit pretty much all of the nearly 400 million devices sometime soon. So I'm going to talk about what features are coming in this update. The very first one is TCP fast open. So the TCP level setting was enabled by default previously, but now we are actually turning it on by default in the browser. So the Edge browser, when it's making a HTTP request, and also determines that there is no web proxy detected or configured, will now do fast open by default to all websites. We did run into some telemetry issues, so we don't have data to share at this point, but we're planning to do a blog post which will have a lot more information about what are the success rates and how many devices are ending up in the fallback state. Talking of fallback, so this is really important because this is well documented that there are middle box issues, so we do have some fallback heuristics. For example, not doing TFO when there's a SYN retransmit, figuring out that we're getting a reset in response to the SYN. There's basically a bunch of heuristics. This is all in the control path, so it does not really impact performance that much. Over time, we do plan to add more heuristics, as we recently found out by talking to Apple this time that there is a middle box that basically stops data transfer on a connection after an idle period, which is something we do not account for at this point. There is an exponential back-off and retry logic. This is all persisted, and all of this information is done per network. So if you're roaming between networks, all of this state is basically start the heuristics from scratch. There is also fully functional server-side support, so you can have two Windows 10 machines basically acting as client and server and be able to do TCP fast open. The request to community is to enable TFO on your services because now you're going to actually see the benefit for a large set of users. Report issues to us, report server success metrics, and of course help fix broken middle boxes. I think the whole point here is to kind of end the Mexican standoff, because if operating systems don't turn this on, fearing middle box issues, then we don't make progress. So this is kind of, I think, the step in the right direction. We now have, oh, sorry.
Just out of curiosity, do you have any measurements on how often TFO is used? Because like not many servers speak TFO, probably so.
So we ran a test against the Alexa Top 500. The only websites that are doing at this point are the Google properties, pretty much all of them, and Facebook.com. So Facebook has turned it on for all of their servers. So those are the servers we see it. But at this point, we do hope that it will grow very fast, because once devices start doing it, people will see the benefit and kind of turn it on in their services.
Do you have any built-in measurements that will be feedback to you, so you get some statistics about if it's working or not?
Sure, yeah. So as I said, we plan to do a blog post which with detailed measurements, but I don't have data to share at this point. We have experimental support for Cubic now. So this is based on the draft and the paper. We did not have to actually, I think the draft covered most of the important points. So we were able to do a full implementation. And when we compare it against the Linux implementation, the behavior is very similar. We do have a fix for the quiescence bug that Jana presented a couple of IETFs back. So basically to avoid having it, if the connection is idle, we don't want to kind of grow the connection window too far. We don't do high start, so it's standard slow start. I would encourage, if you have a Windows 10 system, to actually try it out. You need administrator privileges, but you should be able to turn this on and see how it behaves. We have, sorry.
Quick question. Did you try implementing high start, or was it just not done?
So high start was not very well documented. So there is like a paper about it, but it's not very discoverable and not very well documented.
True.
The exact heuristic. So that's the reason we have not implemented it. But we do plan to try it out in the future.
I wouldn't say I'm a big fan of it, but
yeah, we will measure and see how it works. But the idea is great on paper, but it's not very discoverable at this point. Some of the observations from lab measurements, of course, the single flow performance is better compared to both Compound and New Reno. When we share a bottleneck link, Cubic dominates. Cubic has better RTT fairness, and it does build up a large buffer. So for example, on LTE networks, this might be a problem because it will worsen buffer load. This is some miscellaneous items related to delayed acts in particular. So Windows traditionally had a 200 millisecond delayed act timer. Starting Windows 8, it was a function of RTT, and it was needlessly complicated. So we're switching to 40 milliseconds, which kind of makes it the same as Linux. In tail loss probe, when there's only one packet outstanding, the sender has to account for the worst case delayed act timeout on the other side, because it does not have information about which is the operating system it's talking to. So because that timeout is 200 milliseconds, it makes tail loss probe it's not very effective, because your min RTO ends up being very similar to what you would use for the tail loss probe. So the recovery is not that much faster. Of course, there's you prevent dropping the congestion window down, but it still is not. We could do better here. We tried lowering it, but then there are ping pong apps which, for example, just do keep alives. And if you do this, then there is a lot of spurious retransmissions, and the network traffic, essentially the amount of network traffic increases a lot. The suggested improvement here is that we add explicit negotiation where the receiver tells the sender about what delayed act timeout it's using. The other option obviously is to turn off delayed acts and have some kind of smart heuristic that does it only when needed.
Appropriate byte counting. This is, I believe, 3465. It actually says that there should be a limit of just one MSS in slow start, even when you're counting bytes per rack. But because there is stretch acting happening on the network, there is ACK coalescing, there is LRO. So we actually see that a lot fewer ACKs end up being processed, so limiting the congestion window growth. So Windows was actually already using a cap of 4 MSS previously, and now we are switching to 8 MSS.
Gori, a stupid question. What was LRO?
It's a hardware feature, or it could be implemented in software. It's coalescing of TCP packets. So when you have TCP packets in sequence and their options are similar, you essentially coalesce them into a single packet. And that ends up resulting in just one ACK. So now if you coalesce like 32 packets, it would result in just one ACK instead of 16 ACKs.
Okay.
This is a stats API, which I believe is useful to browser developers or other developers who are using the Windows stack to get more information about how TCP is behaving underneath. I thought this would be useful to the community. So we're adding a new TCP stats API, which is based on the Linux TCP info API. I think is very similar to what information Linux provides. We would like you to give us feedback on what other information will be useful here. We do have it versioned, so we can add more fields going forward without breaking the existing apps. Any questions?
I just want to have a quick comment on the ABC implementation. Linux does a flavor of ABC, but not exactly ABC, meaning that if it gets an ACK of 200 packets in slow start, it's gonna increase the CWIN by 200 packet. And I think we were allowed to, we did that without really causing harm, was because we also use pacing. So you are not going to dump 200 packet right out of the gate. But it's just a quick comment of we don't really implement the exact ABC.
Sure. I think there's a trade-off there. Even with pacing, you might want to use some sort of chunking or batching to do LSO. So we believe that both the IW10 and 8 MSS is a reasonable amount of package to grow it by without pacing. Of course, we could go further if we had pacing.
Yeah, I don't have a problem with that. I think without the limit of without pacing, that might be an appropriate thing to do. On your slide about the TCP stats, I also want to raise this point that I think TCPM should also talk about how we can provide better information to the applications through this kind of stats. Linux has this TCP inform over the years and has lots of stats exported, and applications are using it and they consider it helpful and they often ask more. I think TCP being a black box that there's a pipe, you dump it and then data and it's gonna just transfer it as much as possible, it's not good enough. Application today wants to know what's going on in the network.
So we are running out of time, but at least as individual, I would back the last comment that there could be potential for TCPM work in the letter space. As if there's agreement on what stats are useful, at least what minimum set of stats are useful to app developers, we could definitely look into how to document that, because I would see value if this is agreed between implementations, at least the minimum set of information that's useful. So there could be potential for work, I think.
I want to briefly say that the eStats API, I think, follows the MIV RFC, which has like a list of statistics that operating systems are supposed to provide. But since this is on a per socket basis, some of those extended statistics actually cause CPU usage to increase because now we have to keep more statistics. So this is a lighter way lighter weight version. So yes, it would be great to define a better subset that is really, really required.
As I said, as a lead as individual, I could see this here in TCPM. It seems useful work. But with that, is there a final comment? Because we are out of time, so if there are no other comments, I would like to thank all of you for attending the session, for the discussion, and of course also the authors, and see you again in the next meeting. So thanks a lot.